Hello everybody, welcome to my channel. Today we have an amazing problem for you guys, right? So let's quickly go ahead and read the problem statement, right? So it's called remove element, okay? So it says given an array nums, right, an integer val, remove all the occurrences of val in nums, right? And place. The order of the elements may be changed. Then return the number of unique elements which are not equal to a val, right? Okay, so far what we know so far, right? We're gonna be giving an integer array nums and a integer value, right? And we need to remove all the elements in nums, right, that are equal to value, okay? Now we need to do that in place, okay? And it says consider the number of elements which are not equal to val to be k, right? Okay, so we consider all the elements that are not equal to val to be k, okay? To get accepted, we need to do the following things, right? Change the array num such that the first k elements of nums contain the element which are not equal to val. The remaining elements of nums are not important as well as the size of nums. Okay, very interesting. So what they're saying here, guys, right, what I'm getting so far. So if there are k elements in the array, right, that's not equal to val, right, then the first k elements, right, from 0 to k minus 1, right, need to, from index 0 to index k minus 1, right, needs to be the elements that are not equal, right? So so we need to not only return the number of elements, right, that are not equal to a value, right, but also arrange them in a way such that, you know, all the numbers are at the beginning of the array, right? So that's kind of one of the main challenges here that we have, right? So let's quickly go ahead and so example, so we kind of understand what's going on, right? So the nums array is right here, right? And we have a value thing right there, right? So now for the example, right, we see that there are only two elements in the array that are not equal to 3, right? So that's why we return 2, right? Because what they said to return, right, the number of elements that are not equal to value, right? And then now I told you guys, right, we need to also make sure that in the array, right, that's given to us, right, we organize the numbers in a way so that, you know, the first k element, right, which is from index 0 to index k minus 1, right, are equal, right, to the values that are not only contains, I mean, the values that are not equal to val, right? So we need to somehow, whatever, all those numbers, right, you know, kind of shift them at the beginning of the array, right? Because that's where they need to be, right? And then I think they're gonna check after that, right, from this, right? They're gonna be checking the first k elements, right? That, which is what we're gonna be given to them, right? You're gonna check the first k elements, and then you're gonna see if the values are correct, right? So this is exactly what they did here, guys, right? The first two elements are the numbers that are not equal to, yeah, right, to value, right? So now we have another one right here. It's just kind of the same concept, right? So we're giving val, and so those numbers wouldn't be here, right? So that's why we only contain only the numbers, right, that are not equal to the value, right? So that's why they occupy. So we return k equals 5, which is 5 elements that are not equal to this, right? And not only that, we make sure that we shift all the numbers so that they are at the beginning of the array, right? Yeah, so how do we solve this problem, guys, right? There's a lot of different ways to solve it. Right, so let's see, let's just throw some ideas, right? Let's kind of get so you can get a problem solving, you know, going. It's always good to start brute force, know the most obvious answer, right? And then work our way up to the most optimal answer, right? So that's kind of a good way to go about it, even in an interview setting as well, right? It's kind of always good to make sure you do that. Okay, so how can we go about it at first, right? I'm thinking maybe we could do a for loop, right? A linear for loop, right? As we just do a linear for loop, right? So we check as we're looping through, right? We check, does the value at the index that we're at, right, it does equal to the value, right? If it is, we keep going. If it's not equal to the value, right, then we have some kind of a counter that does +1, right? You know, so for this one, it would just go through, right? It would see that there's only 2 elements, right? That's not equal to val, so then we return 2, right? But we would forget one other thing, guys, right? We need to somehow shift those numbers, right, from where they are to the beginning of the array, right? So that wouldn't be good, right? Because we need to also find a way to make sure all the numbers are at the beginning, right? So that's not enough, right? So maybe we could have some kind of data structure. It could be another solution, right? Data structure we could use to we loop through. As we loop through, right, we add all the numbers that are not equal to val, right? Put them in a data structure, right? So after that, we do the linear loop, right? We do another linear loop, right? But this time, adding all the numbers, right? So we're gonna loop through, right? And then we're gonna start at the beginning of the array, right? As we're looping through, right? So let's say for the example, right? We put two and two, some kind of a list, right? And we loop through again, right? And then we put the first two at the beginning at index 0, and then the second two at index 1, right? And then we'll be done because there's only two elements in there, right? And then we will return that, and then it'll be good, but it wouldn't be accepted. That's a decent solution, right? I mean, but we're using space guide, right? We did say they did say that they don't want us to use any space, right? So it's kind of, we have to be even more creative now, right? So it's very important to do that, right? So how can we be more creative than that, right? I mean, where it looks, we need to not use memory somehow. Okay, so we know we need to do a linear scan, right? Okay, I'm looping through, right? Maybe as I'm looping through, can I somehow modified previous index, like as I loop through, right? How can I do that? Is that possible? So I'm thinking I can loop through as I'm looping through, right? I check if a number is not equal to the value, right? If it's not, then I can place it there, right? But I also need to somehow maintain. Do I need to do some kind of a algebraic solution, like to know which index and I need to put the next one? Or somehow, if I was able to maintain the particular position of where I could place numbers at, right? Maybe I can introduce another verb or another pointer, right, to kind of help me keep track of the next position I could place a number at, right? Yeah, that's it, guys, right? That's exactly what we're going to do. We're going to have one pointer, right, to loop through, right, to help us in looping through the array, right, and then another pointer to kind of help us in to point at a next location that we could place a number at, right? So yeah, so that's how it's going to be, guys. We're going to start with so they're both going to be at the beginning of the array, right? And then we're going to loop through, right? So we check if value is not equal to the so if whatever number that we're pointing at, right, if it's not equal to val, then we replace that number at so we get that number, right, and we place it at whatever I is pointing at, right? Okay, whatever I is pointing at. So let me see if I could quickly just do something real quick so I make sure you guys understand. Like I was saying, guys, right? So we got I and J pointing at the same thing, right? When it starts, and then after we do that, guys, what we're gonna do? See if I could place it here, right? So J would be. So J, so after it moves, right? Because the 3 equals 3, right? So we just move forward. We just disregard it, right? So we just move forward, right? And then we check. Now, does 2 equal to 3, right? Okay. If it's not equal to 3, right? So therefore, we modifying whatever place that the I is pointing at, right? So I will always be pointing at the next available spot that we could place a number at, right? So I was at the beginning, so now we modify it, right? So now it becomes 2, right? And then J just moves forward, right? I'm saying J move forward, right? Because J is going to help us in looping through, right? Not only does J move forward, uh, the I also going to move forward as well, right? Okay, I is going to move forward as well. Okay, so I will be pointing here. Okay, I'm sure I follow. Right now the illustration is not good. I probably should have done a better job, but you guys get the point, right? So we do the same thing again, right? So I is pointing at the next available spot, right? So we check, does 2 equals 3? No, it does not, right? So we modify it, right? So this becomes 2 as well. It's already 2, so I'm not going to change it. All right, so now we go on again. All right, J moves forward, and I moves forward as well, right? And then we check, does this, All right, so we check the it does three not equal to, yeah, it does equal three, right? So it just stays like that, right? And at the end, now we just return the whatever index I is pointing at, right? Which is I, which is index two, right? We turn that to the caller, right? And then the caller will check all the numbers from index 0 to k minus one, right? To check all the first two numbers, and then it would see that we're good, right? So it's got the whole algorithm, right? We have a pointer j, right, and 2 pointers. So we call this technique a 2 pointer technique, guys, right? It's very useful in a lot of different problems, right? So one pointer loops through the array, right, explores the array, and another one that stays behind, right, and helping us place numbers once a particular condition is met, right? So it's very, very important concept that you need to understand, right? Using different pointers to manipulate the array, right? In such a way that you want. Okay, so let's quickly start off with the solution, right? So we got our first pointer and we got our second pointer, right? And then we're going to be doing a linear loop, right? Okay, and so we're gonna do the check here, guys, right? If the number, right, that we're pointing at right now in the iteration, right, does not equal to val, right, then we're gonna just replace that number at I, right, because I told you the I pointer is gonna help us in populating, right, and maintaining the position as well, right? So we replace that with the number that the j is pointing at, right? After we do that, we also increment the pointer of I, right, to go on to the next spot, right? So that way we know, so that we could place numbers at different locations, right? If we didn't move that forward, it would have been updating the same index, right? So we need to move it forward so that we know that next position that we could place numbers at. And after we do that, we always make sure that we increment this pointer, right? So we keep looping through, okay? So a pretty straightforward solution. Let me know in the comment section, guys, if it made sense. Forgot to return um, I, right? Exactly. That's correct. Let's press run code. Looks good to me. Let's press submit. Awesome, guys. Pass all the test cases, guys. So I want to thank you guys for taking the time to kind of watch the video. If you guys found value, make sure to give me a like. If you guys are new here, make sure to subscribe because I'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.